Hello everyone, today I'm going to be talking to you about car safety. The title of my project is Safety on a Road. It means when every pedestrian, driver, passenger or animal is safe from accidents on a road and no one gets injured. I chose the project because I love coding and I'm passionate about safety. The purpose of my project is to make a road safe for all road users. This I plan to achieve by writing tools to control sensors and to enable timely detection of objects or humans within a certain distance and to enable the vehicle to respond appropriately by stopping in order to prevent a collision. This will be tested on mini robots and can be implemented on vehicles. It will go a long way in reducing the number of accidents on our roads. It is also applicable to both new and experienced car drivers. I identified the resources I will need for my project. They are as follows: two robots, an MBot and an MBot Ranger, the Make Block website, the MBlock app, and measuring tape. On arrival of my MBot and MBot Ranger, I assembled both of them and downloaded the MBlock app on my computer. I started writing blocks of code starting with the MBot because it represents the primary vehicle. I wrote blocks of code for both the MBot and its sensors to enable it to detect any object or human form within a certain distance from the sensors and respond accordingly by stopping the MBot from moving any closer to the object or human. This can be another vehicle, a pedestrian, or any object which can cause an accident. After a number of test runs, I decided on a distance of 30 centimeters between the MBot and any object to trigger the response from the MBot. That is, as soon as the MBot sensor detects any object within 30 centimeters of its sensors, it should stop moving and flash red light until the object moves away and the distance becomes greater than 30 centimeters. At this point, the MBot will flash its white light and continue in motion. If, however, the object remains within 30 centimeters of its sensors, the MBot will remain stationary with its red light flashing. After coding the MBot, I wrote blocks of code for the MBot Ranger as well. The MBot Ranger represents any other vehicle on the road. The MBot Ranger and MBot have their own unique coding blocks which cannot be used interchangeably. I do not have to program the sensors on the MBot Ranger, which made the coding a little bit easier than that of the MBot. As part of the project, I researched several websites and magazine articles relating to car safety. These are captured in the bibliography section of my write-up. I also leverage prior knowledge of coding from prior years. After a number of trial runs, the MBot was able to detect any object within 30 centimeters of its sensors, stop with its red light blinking in order to avoid a collision until the distance between them becomes greater than 30 centimeters. I tested my hypothesis using three scenarios as follows. In scenario 1, the MBot is in motion and approaching an object which is stationary. In this case, the MBot is expected to stop and flash its red light as soon as the object comes within 30 centimeters of its sensors. The object in this case could be a parked vehicle on the road. The MBot remains still with its red light flashing as long as the object remains stationary. In scenario 2, the MBot is moving and an object moves into its path. The MBot would stop moving with its red light flashing as soon as it moves within 30 centimeters of the object. It would remain in this mode until the object moves away and the distance between it and the MBot becomes greater than 30 centimeters. At this point, the MBot will continue moving and will begin flashing white lights. In this case, the object could be a pedestrian or pet running across the road or a jaywalker on the road. It may also be another vehicle which mistakenly cuts in front of another vehicle. The third scenario has the MBot in motion and the MBot Ranger in motion as well. In this case, the MBot will stop with its red light flashing as soon as it detects the MBot Ranger within 30 centimeters of its sensors. It would stop in this position until the MBot Ranger moves away and the distance between both becomes greater than 30 centimeters. In this case, the MBot will continue on its path with white light flashing. This scenario can play out on a T or a four-way junction when a vehicle is on the main road and another vehicle makes a right turn into its path. In all three scenarios, the objective was to prevent a collision, thereby ensuring safety on our roads. In the real world, with increased use of technology in our daily lives, this innovation can be applied in the manufacture of vehicles and vehicle accessories to improve safety on our roads for all road users. This innovation with this innovation, there is an indirect impact on sustainability and climate change. The most difficult part of my project was getting the speed right so both the MBOT and MBOT Ranger could move at the same time. I saw this project by testing different scenarios and drawing a graph that compares time taken by each robot to cover specific distances. I also tried different wait times for the MBOT Ranger and recorded my results. These helped me determine the wait time to include in the code for the MBOT. Future research can be performed to include a feature such that the MBOT is programmed to detect lane marks on the road, such that if it's trying to change lanes, it can do so safely while using the object or detection which I initially programmed and the lane detection program. This way, the MBOT is able to change lanes safely while maintaining a safe distance with humans or vehicles. I use the scientific method as follows. I use the scientific method in my project by asking the question, how can I reduce car crashes? The first thing that came into my mind was programming a car sensor. I believe that when I'm done coding the sensor, it can be placed in or on a vehicle, example on the bumper, and it can sense humans or objects when there's specific distance from the vehicle. This detection would trigger a response from the vehicle internal mechanism, which will cause it to stop moving while flashing red lights. It will remain in this mode until the distance becomes larger than the safety threshold set. The vehicle will continue moving and flash white lights. As part of the experimenting, I tested three scenarios as described earlier. Even though I set a threshold set of 30 centimeters for the MBOT sensors to detect object or human form, I noticed it actually detects about a distance of about 33 centimeters, which I consider an additional safety measure. As with vehicles, the MBOT and MBOT Ranger have different startup speeds. The MBOT moves quicker than the MBOT Ranger, and this had to be considered within the code. I had to include a wait time within the code blocks for the MBOT. I really enjoyed telling you about my car sensors project. Thank you for listening and have a great rest of your day.